Okay, now this video continues on with section 2.3. And again, this handout is found under course content, where it's the same place the videos are found. And I'm just going to read to you for just a little bit because I think it's important to set up what we're doing here in section 2.3. It says in section 2.2 we learned how to add, subtract, multiply, and divide functions. But in this section we're going to learn a fifth way to combine functions in order to create a new function. The fifth way is called composing functions. Now what in the world does this mean? Well, the composition of f with g is denoted by f and the little open circle g of x, or you can just use parentheses f of g of x. That's read f of g of x. This is read f of g of x. X is the domain of the function g, and then g of x is the domain of function f. In simple words, you're going to put the function g of x expression, little math problem, into the function f of x in place of x, and then just simplify that result to get your answer. And then of course they're going to ask you to do g of f of x, which is the same thing, just opposite. There's one more thing in this section which is called decomposing functions, but I'm not even going to talk about that until we get to it in the examples. Alright, so let me show you, and of course you can look at number 1 on the handout. If I can get the top off my marker. I'm just going to write f of g of x is what they're asking us to do. And then they're asking us also to find g of f of x. And here are the math problems. F of x is x plus 19. G of x is x minus 19. Okay. So remember, this is just, composition is just a way to put these together to create a new math problem, a new function. Okay. F of g of x. It means take the g of x math problem and put it over here into the f of x in place of x. So the new creation is going to be, instead of writing x, you'll write x minus 19, and then you'll continue with your plus 19. That's the composition. But then the 19s cancel, so your answer to the first composition is just x. If you put g of x, math problem, into the f of x where x is, the 19s cancel and you just have x. Okay, now let's try that again with switching it around. They want f of g of x. That means, let me erase my blue markings here. When you're finding g of f of x, they're wanting you to put in the f of x problem, this problem right here, into the g on top of x. Like, mark that x out and put this problem right there where it used to be, where x used to be. So you'll have x plus 19 minus 19. 19s cancel again, and you're going to wind up with x for the g of f of x. Does this happen every time? Do you always get the same answer? No. No, no, no. In fact, this is just kind of a freak happening. It just does not happen. Let's do number 2. That was just a simple one to get started. They get just a little bit more difficult. Let's look at number 2. Says f of g of x. Find that. Find g of f of x. Here's your functions. F of x is x squared minus 6. G of x is 3x minus 3. Now, please do not make this hard. It really is not hard at all. The hardest part is me trying to explain how to do this. F of g of x means the g of x math problem is substituted into f of x in place of x. So you're not going to have that x anymore. You're going to have 3x minus 3. That's going to be squared because, see the square there on x? You can't mark it out. You can only mark out x and put in a new math problem. Take away 6. Now guess what you have to do? You have to simplify this, which means use your FOIL. Multiply 3x minus 3 times 3x minus 3.
What's FOIL?
And of course, those of you who might have forgotten what FOIL is, it's just a little acronym for multiplying binomials. The F stands for first, so you take these first 2 items and you get 9x squared. The O stands for the outside, which is the 3x again, but with the negative 3. Outside items, that's negative 9x. The I stands for the inside items, which is negative 3 and 3x, which is negative 9x. And then the L stands for these last 2 items, which is negative 3 times negative 3, positive 9. So what you'll put up there in the blank for f of g of x is 9x squared minus 18x plus 9. And again, they're asking you to do this again, but with g of f of x. So take your same 2 functions, the most inside function tells you what to start with. Take your f of x, take this, and put it into the g in place of x. So you'll still have that big 3 out in the front, but instead of x, you're going to send in this expression, but you'll still have your minus 3. Simplifying that is not FOIL. This is just a distributive 3x squared minus 18, take away 3. Your answer that goes in the blank is 3x squared minus 21. Now, after you fill in those 2 blanks, number 2 also asks for the domain. It asks for the domain of your answers you got. Domain of f of g of x, f of g of x. What is its domain? Just look at your answer. Do you have a fraction? Do you have a radical? Square root? No. So there's your domain for the f of g of x. Domain for g of f of x is going to be the exact same thing, negative infinity to infinity. Why? Because there's no fraction, no square root. And that's pretty pretty much what you're doing in section 2.3. It's just that they changed the functions to make it just a tad bit harder. This time in number 3, the g of x is a square root of x. So when they ask for the f of g of x, the principle does not change. The technique, take your g of x, this expression, square root of x, and put it on top of x. Don't just take the x out of there, so you'll have your 4, but you're going to have a square root of x instead of x, and then you still have your plus 1. Be sure the plus 1 is way out, not underneath that radical. And then they ask for g of f of x, which means this time you're taking the f of x math problem and you're putting it into the g of x, but just on top of x. You still have the square root, but instead of just little simple x under there, you've got to replace it with f of x. And that's your 2 answers for the composition. But now they're asking for domain. Domain of f of g of x, and then the domain of g of f of x. Now, do you see what I see? I see square roots. My board is just not quite big enough to handle all this square root stuff. If you're wanting the f of g of x domain, you look at that, and you take that x out and you say, x has got to be greater than or equal to 0. So your domain is going to be bracket 0 to infinity. If you want the domain of g of f of x, you're going to have to take the 4x plus 1 out and say, hey, you got to be positive or 0. So put greater than or equal to 0. Move the 1 over, it becomes negative. Divide by 4, and you get x greater than or equal to negative 1/4. Domain for the g of f of x will be negative 1/4 to infinity. I'm looking at my handout to see what number 4 was very much like that. I'm looking at number 5. I think we need to take a look at number 5. F of x is 3x minus 9. G of x is x plus 9 divided by 3. What's f of g? Take this g of x math problem and put it right there on top of that x. Take the x out and put the fraction. And by the way, this is not a bad fraction. The x is in the numerator, so it's not bad. In fact, now it's really not bad, because look what happens. This 3 cancels that 3. This is division by 3. This is multiplication by 3. That cancels. And then this positive 9 and that negative 9 cancels. X is your answer. Let's let's just go ahead and answer the domain, because we know they're going to ask that later on. The domain of this is negative infinity to infinity, because x has no troubles, no fractions, no square roots. And you know the routine by now. They're going to ask you to find g of f of x. G of f of x. Which means put the f problem in place of x. So you'll have, don't put your x anymore in the g, put your 3x minus 9 plus 9 divided by 3. The negative 9 and the positive 9 cancel. This 3, which is multiplication, this 3, which is division, cancels, and you get x again. Domain, negative infinity to infinity. I only took a look at that one because I thought you might want to, or you might get a little bit afraid of that fraction, but it turns out the fraction